This is the third video of the day. We are going to solve by using the square root method. This method works great if you have or notice perfect squares in your equation. So always kind of have these perfect squares in the back of your mind and be on the lookout for them, because if any of them pop up, this root method is definitely a nice way to go to solve a problem. For example, if I give you x squared equals 144, that 144 could maybe be a red flag to you that you'd want to use the root method, because that is a perfect square. So what you do for this, it tells you first to get the squared item isolated on one side of the equation. Well, the x squared is the squared item and it is already all alone. So then all you have to do is take that square root of both sides. So what times itself equals 144? A positive 12 would do it, and a negative 12 would do it. So x equals plus or minus 12. So that's telling you on your parabola, if you go out to positive 12 and negative 12, your parabola would have x-intercepts there. I'd like to illustrate how you would solve this by factoring, because you totally could do this with the factoring method as well. First thing, you would get the equation into standard form, and then I would look at this and rewrite it that the b value is really like a 0 here. So I could rewrite this equation as x squared plus 0x minus 144. I'd ask myself, what multiplies to a negative 144 and adds to 0? Will be a positive 12 and a negative 12. And like you learned in the first video then, or video number 2, I should say, you set both of these equal to 0 and solve for x. So then again, you'd get the same answer of a plus or minus 12. So factoring method does work, but square root method proved to be a little bit faster. So be on the lookout for those perfect squares. Let's try this problem. We're going to solve this using the root method. When I initially look at it, I don't see any perfect squares, so I don't really recognize that that would be the way to go first. But I am going to try it, and I'm going to isolate the term that has the x squared in it. So to do that, I'm going to subtract a 1x squared from both sides and add an 11 to both sides. So what happens, I end up with a 2x squared minus 1x squared is x squared. That cancels, that cancels. I have an x squared equals 16. Now that 16 is a perfect square that's shouting out at me that now I can take the square root of both sides. Square root of 16 is a plus or minus 4. So this parabola has two roots or zeros at a plus or minus 4. The a value is positive, so I know it's going to be facing up. Let's try one more. Last one for this video. 3 times the quantity of x squared minus 1 equals 9. That 9 makes me think that maybe square root method will work, but I'm really not sure yet, but I'm going to try it. So I'm going to work on isolating this guy right here. So to get that guy alone, I think the first thing I want to do is divide both sides by 3. Many of you would want to distribute that 3, and you can do that. That would work out as just a few more steps. Then, no, let's try that again. X squared minus 1 equals 3. When I add 1 to both sides, I get x squared equals 4. Then it's clear that that square root method will work for me. When I take the square root of both sides, I get a plus or minus 2. So if I was going to sketch out this parabola, I don't know much about it, except that I do know at a plus 2 and minus 2, the parabola will cross the x-axis. That is it for square root method.